Okay, in this video, we're going to go over the quiz that you guys took on uh, Thursday or Friday. Um, we're going to run through what was expected of you on each part of the quiz. And then also, we're going to talk about a little bit about how to go back and fix problems that you're having. But since that will make the video a little long, I think it's best if we come back to that point in a separate video. We could talk about how do you catch up if you're having issues. So there are two different versions of the quiz. The first version starts with the data table, and the second version starts with a diagram of phase changes. So this very much, when you're getting ready for a quiz, pay close attention to the first quiz you took that week and also whatever board work we did that week. So your first quiz of this week started with a very similar data table, except I identified the substances. I said, hey, this is copper. Hey, this is ethanol. And then you were supposed to answer some questions on physical properties. A lot of you did pretty well on that. What you were doing in addition this time was adding on density as a conversion factor, and then still working with ideas about physical properties. And then a little bit, we added phase change when we talked about the beginning about solid liquids and gases and the converting between phases. We did this as board work. Um, and we talked about some of these phase changes. And then there was just a teensy bit of solubility because I don't think we're ready to actually talk about reading stuff off the solubility curve, but we'll be doing that in class next week. So then that's going to start to get included on your quizzes next week. So typically, that first quiz of the week is only 10 points. That's where we start to kind of explore whether or not you can do some of the things you were doing in the notes. Then we're doing board work to refine it. Then we're doing board work again to refine it. So the pattern this week was you did board work and then you took a quiz, and then you did board work and then you took a quiz. The purpose of the board work is to get up and really practice the skills while you have people to ask questions, where you could talk to other students, where you could ask me. And that is really the guidance as to what's on this quiz. So starting at the beginning of version one. So both quizzes have the exact same style of question because you're being tested on the same skill, but the different versions have slightly different problems. So, for example, number two and three had slightly different numbers on each version and had maybe were referencing a different substance. So, you had to put in a different density. That's obviously, I do that so that to prevent cheating, but it is testing you on the same skills. You're not getting drastically different versions of the quiz. So the basic skill for questions one and two, sorry, the basic skill for question one was, could you use the density formula to calculate? And so one of the things I did on the answer key, this answer key also, if you don't want to listen to me talk, is posted on the work plan as it is. And some things I'm doing here, you're going to notice me numbering things. One, two, three. Let me annotate. Right. So I have these little numbers here, one, two, three. What I'm doing is I'm showing you how to read through the question and identify the important things, right? So the first thing I asked you to do was imagine that you have another sample of substance B. So I did have some of my sharper kids were like, but I already know the density of substance B. Yes, I know that. But what I'm testing you on in question one is, can you calculate the density of a substance? So I'm going to give you a different sample size and ask you to calculate it again. Now, if you're bright, you might have noticed that you should be able to check your answer against the data table and see if you're doing it right. So in some ways, I did that on purpose because it offers you a chance to demonstrate to me the skill. So let's go through how this works in terms of understanding application and fluency, right? In terms of fluency, I asked you to show the formula. That was number one, right? So did you show me the formula? So here in my answer key version, I'm going to show you the formula, right? So one, did you show me the formula? That's fluency. You memorize the formula for density. Do you understand how to use this formula, what everything represents? And so understanding and application here are going to go very much hand in hand because you have to understand what mass is, what volume is, what their units are to make sure that you plug in correctly. So here I have it that I plugged it in. I followed what was requested of me in what I circled as 3. I showed all my work and all my units. Okay, I didn't drop units. I didn't show half my work. I didn't do it on the calculator and show an answer. Okay, this is what you're being tested on. I'm not testing you on whether or not you can produce answers. I'm testing you on whether or not you can think your way through problem solving. So there's a big shift here in what you're used to. And the reason why we're shifting that way is A, because that's what real learning looks like, but also B, because that's what they're going to be testing you on in the regions. So if that's what I have to train you to be able to demonstrate in writing that you know what you're doing, right? And so I presented you here with an answer. That's the calculation of the density. And that was what I said in that I numbered as 2. 2 is what were you supposed to do? You were supposed to determine the density of this sample. You were supposed to find the density. Okay, so you were given a mass and a volume. You needed to provide me with the formula, plug it in correctly, show me all your work, show me all the units on your answer. Okay, most of you got that. I'm pretty sure. I haven't actually graded these yet. I'm a little scared to grade it, you guys. All right, so let's turn off my annotating. Let's go down to the next one. So both question ones would have been done this way. The only difference between, both the density questions would have been done this way. The only difference between the versions is you would have been doing different numbers. So same idea, right? And I wrote it down for you on the answer key. Notice I did what is asked for, right? I showed the formula. I did the calculation with all my units. I showed all my work and I showed all my units in my answer. Okay, so question 2. Question 2 and 3, the skill I was testing you on was whether or not you could use density as a conversion factor. So if you had issues with these two problems, 2 and 3, then chances are you don't understand what conversion factors are. You don't know how to use a conversion factor, or you don't know how to use density as a conversion factor. Now, I went back and redid the slideshow, the density and conversion factor practice slideshow, because I recognized I made a mistake. I did not have the problems worked out for you. I gave you the practice problems, but I didn't show you what they should look like if you were doing them right. So you may want to go back and take a look at that if you're having trouble with this. If you were fine with metric conversions and you're having trouble jumping to density as a conversion, then you're sort of just having an understanding problem and a little bit of an application problem. So there's a number of different things you might need to fix here if you don't know how to do these problems. In terms of just understanding the questions, these were exactly the same as 2 of the questions I gave during board work. So I gave you these questions during board work and then I quizzed you on them the next day. So if you're not walking out of your board work, absorbing things and then going home and practicing them, that's going to be a little bit of a problem. So I underlined a bunch of things. First of all, I asked you to use density as a conversion factor. Then I told you what I wanted you to find, determine the volume of the sample. Okay? Then I gave you some data to work with. Your sample has a mass of 45 grams. And then I asked you to please show all your conversion factor work below with all your units. And then I said in bold and capital letters, you may only use conversion factor technique to get credit for this question. Okay. I do understand that you guys know how to plug into this formula and put X where volume is and solve for X. That is not what you're doing. That's not the skill I'm testing you on this quiz. Okay. What I'm asking you to do is move to a higher level of science work and work using dimensional analysis, which is a higher level technique we use in chemistry and physics. I am not asking you to do this the way you have done it in the past. So again, I'm not concerned about your answer or whether or not you can do math. I'm concerned about whether or not you can use this new skill you were supposed to learn for chemistry and physics, which is can you do dimensional analysis, which is using conversion factors to change from one unit to the other. Okay, so that's why the work is on the test is requiring you to provide your answer and your work in a particular format. It's not because I want you to do it my way. It's because this is actually a skill that we use in chemistry and physics that you need to learn how to use, and I want you to be able to do it. So the first version, I kind of broke it down a lot for you. Here I talked about what were you given, what were you finding. I wrote out all the different conversion factors this density could be made into, and then I showed you the order of the math. Okay, when you're working with a conversion factor, you should always start with what you're given. You are then timesing that whole thing by the conversion factor, by the conversion factor. So what your math really looks like is down here. It looks like 45 times 1 over 8.94. That's what's going to get your answer. I have a lot of people who are actually setting up correctly, but you are doing the calculation in the wrong order. So the example that I gave people while we were doing board work, and I think it was fairly effective in terms of getting people to understand what I meant here, is I said to people, if you took 30 and you times it by 1/2, wouldn't you be doing 30 times 1 over 2? That would get you 15, right? Basically, you're doing half of 30. That's exactly what you're doing here. It's the exact same math. You're doing 45 times a whole fraction. You are not cross multiplying here, and this must be a multiplication sign, not an equal sign. So if you're still making that mistake, I will be patient with it and I'll keep circling it or Xing it out because I want you to pick up on the fact that the reason why you might be doing the math in the wrong order could be because you're trying to write this as a proportion. A proportion is when you set two fractions equal to each other. We do not use them for conversion factor math and chemistry. We will use proportions, but we won't use them for this, right? So there's a very good reason why I don't recommend you use proportions for this, and it has to do with limiting how many steps you can solve a problem in. But so this is why we don't do it this way. I'm teaching you to use any number which has two different units, a derived unit, um, as a conversion factor because this is a higher level skill required for chemistry and later for physics if you move into my physics class. And so that's why I'm trying to get you to move to higher level thinking strategies on these types of problems. Okay, so I have both of these all done for you. I'm not going to go through them in individual, but again, on the second version, the only thing that changed were the numbers. And here again, I showed you the order of the math. So on your last quiz that I graded and gave back to people, I gave you a little pointer and I might have said, hey, this is an understanding mistake. This is an application mistake. For many people who I caught you doing the math in the wrong order, I specifically told you to go review certain slides in the conversion factor slideshow to make sure you understood that you were doing the math in the wrong order. So I'm going to show you quickly where that is. So if you go back on the work plan to the conversion factor slideshow, let me just double check my screen sharing. Sometimes I do this and then I'm not sharing the same screen. All right, I specifically went and wrote, please go look at slide number 12, which clearly says that you will not be cross multiplying. Okay, I have it all highlighted for you here. Conversions are not done like other math you've seen before. Okay, you have worked with proportions and cross multiplied. You will not be doing that with conversion factors. I clearly said it because I already see these mistakes every year, so I know that you're going to do it. And I clearly say, and it's highlighted, you will not cross multiply. Okay, so if you keep going in this slideshow, you will see that I show you the order of the math. Okay, on slide number 20, Do you see how I show you, you're multiplying 2 gallons of honey by this fraction. Underneath, I show you that that looks like 2 times this number divided by whatever's in the denominator. And this is canceling out the units. Okay. So this is all in the slideshow. You need to make sure you go back and do your understanding and your application. Really make sure you understand it. One of the glaring issues, one of the really big issues I saw in everybody's notes when they did the conversion factor notes was that they did not do enough application. So, application is when you practice in your notes how to do the thing that you're supposed to be able to do, if that makes sense to you, right? So if it's problem solving specifically, like you see that there's some math or some formulas associated with something, you need to practice in your notes, making sure you know how to do that independently. So there are some repeat questions on this quiz. So we're going to go ahead and go over those. So now these written questions, what I want you to practice when you're doing these written questions is I want you to practice paying attention to the language and providing the correct answer based off exactly what you were asked to do, right? So you guys tend to be generalists. You try to talk about things in general and hopefully you hit the right answer. I would like to train you over the next year to give targeted, clear answers to exactly what questions are asking you. Okay. Now, this is going to get increasingly difficult because the way the questions are being written seems very vague and very general. They frustrate even me, right? And so now I'm forced into a position where I have to design questions that sort of set you up to practice this, which I do find a little bit frustrating. Okay. So let's look at question number 4 together. State which 2 substances on the data table, right? So this word state means that you have to write which 2 substances on the data table you're talking about. Okay, so to state something is just to say it. Okay, so some people just did that and then they didn't finish the rest of the question. Okay, what 2 substances am I looking for? I am looking for the 2 substances that could have the same identity based on the physical properties that you're seeing on the data table. So another question I got during the quiz, which was like, what are those things on the data table? So let's scroll up for a second. These things up here, let's change colors for a sec, right? Phase, density, mass, boiling point, volume. These are physical properties. That's what they are. Okay, they have names. They're physical properties. These are different types of characteristics of substances I can observe and measure. That's the definition of what a physical property is. Okay. Can I observe that oxygen is a gas at room temperature? Can I observe that ethanol is a liquid and copper is a solid? Okay. You did already actually have some interactions with copper, which is my favorite element. So you're going to see it a lot in the lab. If it were up to me, it would be everywhere. So that phase is an observable physical characteristic. Okay, it's something, a characteristic is something I can use, I could talk about that describes the substance. So a lot of this traces back to your language skills, which remember, whenever I say that you need to improve your language skills, that does not mean it's your fault that your language skills are where that they are. What I mean is, for whatever reason, you're not fully using language or absorbing or understanding language the way you need to be able to do these questions. So that's what we're going to work on. That doesn't imply anything about how smart I think you are. Most of these issues are coming from the fact that we're just not using language enough to make it so that you're able to tackle these tests. And so we're going to use it and practice it a lot more, because in my classroom, we don't think of this as whether you're smart or you're not smart. We think of this as this is what your brain needs to learn to do, and it's going to grow and learn how to do it. We're building skills, right? So we're going to always think of this as a skill. Do you know what a physical property is? That requires the skill, the language decoding skills of recognizing what observable and characteristic mean, right? So observable is something I can either look at it and see it, or I could also say measurable. I could take a measurement of it. And you guys have actually already been up in the lab to do that. You measured the mass of samples. You measured the volume of samples. Okay, we're not going to be taking any substances boiling points because we don't have the no high school I know of has the equipment to reach temperatures of 2,562 degrees Celsius. But we can measure density. We will measure mass and volume in the lab and calculate density. Um, we'll be able to physically observe with our eyes the phase of matter that something is at. And so these physical properties are all characteristics of substances I can measure. Okay? Measuring those properties allows me to make well-reasoned arguments for why I think a substance is the substance I say it is, right? So intensive properties and extensive properties are measurable physical properties. Extensive properties change depending on the quantity of matter that I have. Well, intensive properties are not dependent on the quantity of matter I have. So, an intensive property, because it will be the same no matter how big or small my sample is, means I can use it to identify a substance or at least get me close to it, right? An extensive property will always be changing depending on the quantity of sample I have. And so I cannot use extensive properties to identify substances because it will be altered every time I change the quantity. So a lot of you are shortening that sentence to um, it changes. That's not specific enough. It changes based on quantity. And it's very important that you hang on to all of those words because that's what's giving it its full meaning, right? So I wrote for this, I stated, that was the first thing that they asked me to do, right? They asked me to state. So I stated it. It's substances C and D. Now we go on. What else did they ask me? I need to support my claim using data from the table. So I had several people call me over in the middle of the quiz and say, do I have to actually write numbers from the table? Yes. Yes, that's what it says to do. It says to support your claim using data from the table. You can't just say substances C and D. This is science. We use evidence to support our claims, right? And this is why you're going to be tested on this skill, right? This is the shift in the new curriculum is that we're shifting away from can you give me the answer, and we're supposed to be moving towards if you're telling me that's what's true, can you give me evidence that proves it? Because that is what the practice of science is supposed to be about, right? It's not really just about proof, because we may find that things change over time, but what does the evidence say right now? Right? So, what does the evidence that's in the table? I say both of these substances have a density of 8.49 grams per milliliter. That's data I took off the table to support my argument. And I took data showing that they both had the same boiling point. And then I said that that demonstrates that they have the same identity. So, this isn't about how I would do it. This is about how you make sure you're fully answering the question. And you guys have not really been practicing how to thoroughly answer and analyze questions. And that's something we're going to be real focused on in my class. All right, let's talk about number 4. So I tell you what samples and what's going on with them, right? I say samples B, C, and E all have the same mass. Okay, that's not the question, obviously. My favorite I shouldn't say my favorite, my least favorite thing that a student will do is they will repeat something that was stated in the question and think that was the answer. So if you were to write as your answer to this question, well, substance B, C, and E all have the same mass. Yeah, I know. I told you that in the question, right? So this always frustrates me when I'm grading part twos on Regents exams, is when students think that they hit the answer, but they just restated something that was in the question. So you're not going to restate things that are in the question unless it's necessary to make sure you're clear about what your answer means. We'll get into that another day. But can this data be used to determine if all three samples have the same identity? So the first thing you have to do is answer that question. And the question, really, the core of this question is, can mass be used to determine if all three samples have the same identity? The answer is no. Why? Now, the next question is why? So what this question is really asking you is, do you know the difference between extensive and intensive properties? That's an understanding question, right? And on the board work, if I'm not mistaken, I put, can you compare and contrast? Can you compare and contrast extensive and intensive properties? Okay, and a lot of you are actually still having an understanding mistake where you're just reversing the definitions. You're telling me mass is intensive and density is extensive. That's backwards. You have it backwards. Okay, so if that's the kind of quick mistake you're seeing, that's pretty easy for you to correct, but it does mean that you have to go over it a little bit more, right? Mass cannot be used to determine identity of substance because it is an extensive property. Extensive properties change when the amount of the sample changes, so you cannot use them to identify things. This is actually more of an explanation than they would typically even ask for on a Regents. I gave a pretty advanced answer because I'm the teacher, so I have more advanced ability to do that. But if you had just said the first sentence, mass cannot be used to determine the identity of a substance because it's an extensive property, that would be enough. That would be enough because you are explaining it well enough. I went the extra mile to add this second explanation because if you're using this answer key to correct your misunderstandings, I wanted to make sure you understood that. All right, now let's look at two-step conversions. I'm sure you're all very excited about that. All right, a two-step conversion is a conversion that requires you to change units twice to get to the final unit. Why? Everybody says to me, why? Why do I have to do all these steps? Because there is no direct route to get there, right? It's like, why do I have to change buses to get to school in the morning? Because there is no bus route that goes straight from your house to the school. That's why. I wish there was. So you have to change buses. That's all you're really doing here is changing buses. There's no direct relationship between inches and meters. If I had that conversion factor, I could do it as a single step. And there is a conversion factor for that. Why then? Why am I not giving it to you? Am I a jerk? A little bit sometimes. But no, it's really because I want you to practice moving through multiple units. Because when we get to the end of quarter two, we're going to be doing fairly complex conversion math, something called stoichiometry, which we use as chemists when we're working with chemical reactions. It is a math that is truly unique to chemistry. And it basically has to do with the fact that we use a unit of measurement that's truly unique to chemistry, and that is the mole. You can thank the physicists for nailing that one down for us. We developed it, the chemists developed it, but the physicists actually proved it on atomic and molecular level. So most of the stuff that gets really complicated in chemistry is the physicists' fault, so you could blame them. All right, so I need to do two-step conversion here. Now, I told you, see, I underlined it for you. I said this is a two-step conversion. Okay, how could you do a two-step conversion problem? You're in the middle of a test. You're immediately feeling anxious because you feel like this is a lot of work. What could you do? You need a framework here for how you're going to solve problems like this so that you have a set number of steps that you're always going to follow and you understand what to do first, what to do second, what to do third, and you can make a plan, you can do it quickly. That, my friends, is application. Okay, how do you practice that? The only way to practice that is when you're doing your application section of your notes, you need to create your own systems and steps for this. But there is some general advice that I can always give students, and I'm going to put this, let's clear my writing off for a sec. I'm going to put this in a program called Paint, and we're going to do this problem together step by step. And it's going to be that you guys need to learn how to make this a framework. What I mean by framework is you're going to create a sort of guiding system. Now, I went over this little guiding system in the study guide for conversion factors. So before I move us over to Paint, I'm going to show you where that is really quick. So if you go back to the work plan, let me just make sure we're screen sharing. If you go back to the work plan, when you guys went over conversions, some people did better. The conversion factor, so anytime I give you a study guide, that study guide is not necessary, but it is there to help you process, right? Because you might find that what's in the slideshow works better for you. But if what's in the slideshow is not making any sense to you, I may have provided you with a study guide where I broke it down or summarized it in a way that makes more sense to you. You may also find in the slideshow that I gave you a video. So I'm giving you multiple tools. If you choose not to use them, that's on you. If you're waiting till the last minute to do your work, you're not giving yourself enough time. So you really have to give yourself enough time to make decisions, to look at all the materials and be like, this is the one I'm going to go with. I like the example you did in the slideshow. I like this video. I like this study guide. Right. So you may find that the study guide contributes in some way, or you might not. Right. So this study guide was actually designed for kids who are visual processors. Why is my right? I'm going to go to it through the drive. It is linked to the work plan. So this is called visual help using conversion factors. And the reason it's called that is because I designed it for people who would prefer to look at pictures. They want a visual explanation that works through everything for them, right? And so here's a visual of measuring tools. Okay. In this example, I tell you how to do conversion factors, and I kind of break it all down for you. So this is a visual framework for how a conversion factor should work. Okay, you're always going to start with a unit that's given. Your conversion factor is a rule. Okay, it's a rule that relates to two things that is definitely true. And then your answer is going to always be the unit you want to keep, and you're going to have one unit that cancels out. And so I always say a conversion factor has two units. We started to say this last year. It's kind of sing-songy and it sticks for fluency reasons. A conversion factor has two units, one to cancel and one to keep. It's like my little nursery rhyme about conversion factors, right? A conversion factor has two units, one to cancel, one to keep. Okay, so conversion factors have to have two units. That's the bottom line. So this first step that you're going to be doing when you do a framework, I'm going to stop sharing for a second, reshare my screen, because we need to do with Untitled Paint. All right. So when you are doing conversion factor math, what you should find is that you need to do a few different steps here. Sorry, guys, let me just get my marker set up. I'm a big fan of doing everything in color. Oh my gosh, why is my paintbrush that size? That's too big. Okay. Oh, why is it in black? I don't want to be black. I want to be in blue. Thank you. Okay. So when you're problem solving, particularly from word problems, you want to lay everything out before you start so that you understand what you have to work with, right? I tell you up front that this is a conversion, and I even tell you how many steps it's going to take. Okay. A two-step conversion means you need two conversion factors. Two conversion factors. Okay. So one of the conversion factors is given to you in the problem. The other one was supposed to be using your knowledge of the metric system. So you have a lot of things you have to determine here. You have to determine first, what are you given? Then you want to determine what you need to find. And if part of those givens are conversion factors, you want to probably make a list of those. Okay. So let's make a list together. What am I finding? Usually, for some reason, you guys tend to figure that out faster. I'm trying to find meters. Okay. I am given 6,754 inches. Okay, so my target goal here is to go from inches to meters. So I often describe this as a map, right? How do you get from point A to point B to point C? Okay, I need a path that goes 2 meters from inches. Here is my first conversion factor. It's given to me in the problem. This conversion factor has, get rid of that decimal, has centimeters and inches. So this conversion factor will get me between inches and centimeters. Now, once I have that conversion factor and I know I have centimeters, the second thing I have to be able to do now is get from centimeters to meters. Do I, in my head, know the relationship between centimeters and meters that I could write a conversion factor that will get me from centimeters to meters? I should, in my head, have the conversion factor that there's 100 centimeters in 1 meter. And now I have a path, a two-step path. Okay, let me try and put this in a different color so you can see what I'm doing. I'm going to go inches to centimeters, and then from centimeters to meters, and that's my map. Okay, now by no means do you need to do this as one continuous conversion. If you need to do this as 2 separate steps, you can. But if you start to think of this as one path, right? This is, say I was flying on a plane. I'm going to go from New York to Colorado. Why is this on my head? Because I have to go see my sister at some point. I go to make plane reservations, and they will not give me a single direct flight. This is a real story. They're going to make me fly somewhere else and then take a connecting flight. That's all you're doing here, right? I'm in New York. I want to go to Colorado, but first they're going to make me go to Texas, right? You are in inches. You want to go to meters, but you can't get there directly. So first you're going to go to centimeters, sit in the airport, have a snack, and then you're going to go to meters, right? And you're going to use these 2 conversion factors. That's what you're going to do. So here's your starting point times your first conversion. Your first conversion is you're going to keep these numbers exactly the way they are, meaning that everybody stays with the units they already have. So you're going to put 1 inch on the bottom, but notice that I don't separate the 1 and the inches. Okay, because that one, it belongs to that unit, that number. So you're not allowed to just take them off. Then you're going to do 2.54 centimeters. In this first step, I have now canceled out inches, which means I'm halfway there. I'm sitting in the airport at centimeters. Okay, now I'm going to get on the plane again. And this second flight, the second bus, whatever our mode of transportation is, the transportation analogies are new for me. I just came up with them this year. All right, so now I need to use this second form of transportation. This second conversion factor gets me from centimeters to meters. So I'm going to put 100 centimeters on the bottom. Again, this 100 belongs with this centimeters. I can't separate them. I don't put the 100 separate from the centimeters. And I'm going to put 1 meter on the top because that's the unit I want. The unit I want, so here's my unit to cancel, my unit to keep. Okay, cancel, keep. The one you're keeping, you always want to be on the top because it's the one that's on the bottom that's going to fall diagonal, is going to cancel. Okay, now what's the order of the math here? This could get confusing. What I'm going to end up with is 6,754 inches times 2.54 centimeters times 1 meter all over 1 inch times 100 centimeters. Okay, so essentially everything on the top is multiplying across. Everything on the bottom is multiplying across. But people have to stay in their lanes, okay? Your people who are in the numerator, people who are in the denominator. The only way to get these people up is to divide them, right? So you're going to divide this by these numbers, okay? And then in the end, the answer key has it all worked out for you. But notice when you line it up like this too, it probably might be a little clearer to you. Do you see that these things that are in the numerator and the denominator are canceling out? They're canceling out. So you're left with units of meters when you're finished. And that's the whole goal. Okay? That's conversion factors in a nutshell. That's what they do. They get rid of units you don't want and they get you to units that you do want. Okay? And now this study guide goes over it in detail, but what we want to be focused on right now is finishing this answer key. Okay, so both of the conversion factor problems, I'm not going to go over both of them, can be done and set up this way. Now, if you're checking your work, you should be using the number to just kind of get a sense of whether or not you did this right. A meter is a much larger unit than an inch or a centimeter, and so you should have fewer meters than you had inches. The number should be getting smaller as the unit gets bigger. Right, so both conversions are going to work that way. If you need the answer to the other one or you want to check your work, I did both of them as two separate steps so that it was a little easier for people who are having trouble with continuous conversions. It might be a nice target goal to get you to a place where you are doing it as one calculation, but you don't need to. All right, last but not least, this is a correct way to show particle diagrams. So, very first thing I would point out to you again from an understanding standpoint is you have to, I don't know how to say this in a nicer way. I'm going to sound like my dad yelling at you. Freaking read the directions. Read. You have to read the question. You can't just go down and start filling in because you might not be doing what they want you to do. So you can't just make up what you would like the question to be asking, especially on a state exam. You have to do what they would like you to do. I appreciate your independence, but this is not the moment to express it. Okay. So please complete the diagram below by filling in the particle diagrams. Now, this is something they may not do for you and that I will do for you. And that is that I provided things that were important are written in bold to help you to realize I have to read this. Okay, so fill in the particle diagrams was the short and sweet part of that. So make sure you write what should a solid look like, what would a liquid look like, what would a gas look like. Most of you that I saw either just accidentally skipped this or you were doing it correctly because we did board work on this. So people already have started to correct their understanding of what this should look like. Okay, and then the second step is to identify each phase change. So now if I'm grading, I haven't graded these yet. If I'm grading and you see me do this, see all the circling I'm doing like this over and over and over again? I call that angry circling. It is because you're not reading carefully. And so you may have done something different than what you were supposed to do because you weren't reading carefully. Okay. A phase change is different from a phase. Okay. The phases are solid, liquid, gas. That's the state that the matter is currently in. It is currently a solid. It is currently a liquid. It is currently a gas. A phase change is how it gets from one state to the next. And so we have a different word for that, and it describes some process that we can observe, right? So if you would like to go from a solid to a liquid, the change, we call that melting, freezing. evaporating, condensing, right? The ones most people got stuck on, and you're going to be able to do this a lot more because we're about to do a whole unit on heat, is deposition and sublimation. Deposition and sublimation are important phase changes. They are less common phase changes, but they do happen all around you. You just don't really pay attention to them. They're a little bit harder to pin down. Okay, so deposition is when a gas goes directly to a solid. This requires a rapid and sudden change in temperature, and a drastic change in temperature, meaning you go from a really high temperature to a really low temperature quickly. Um, you can go in your kitchen, pause your video, go in your kitchen right now, open your freezer, and watch watch sublimation happen. Sublimation is when a solid immediately goes to a gas. Again, a very extreme temperature change. But this is particularly true in the summer if it's very warm, and then you open the freezer where it's below freezing, and the water that's in your freezer experiences a sudden and rapid change in temperature. And so you will see it go directly to a gas. That mysterious white mist that comes out of your freezer is subliming water vapor. It's water vapor that is immediately becoming a gas, um, and that's what's causing it. So you'll see condensing every time you get in and out of the shower. The water vapor from your shower running will then condense on your mirror glass. Some of us had these conversations. All right, so we're going to go into this a bunch more times. You have not seen the end of this diagram. Okay. So just be aware that if you didn't know it this time, you need to know it. Um, okay. And then for the graph, table G, we talked about this in class. I explained to everybody that the only table G question I was going to be asking, you're not going to start getting more quizzing on solubility until next week. So the solubility diagram for right now, all I want you to be able to find on the graph is whether or not in general solubility increases or decreases based on the temperature. Okay, graphs are very good ways for us to check general relationships between two variables. And the two variables on the solubility curve are solubility of a solute in solvent and temperature. Okay, so we'll talk about that some more in English later. But you should have had, as temperature increases, solubility increases. You could have written the trend backwards. You could say, as temperature decreases, solubility decreases. That's also true. So it's up to you. These are open-ended questions on purpose so that I don't mark you wrong if what you're saying is correct. So same thing here. If it is something like a gas, like hydrogen chloride or ammonia, on the reference table, it will show you that as the temperature increases, the solubility is actually going to go down. These curves are inverse curves. They go from a higher point to a lower point. Same thing is true as if you were to lower the temperature, you could get the solubility to increase. So decreasing temperature increases solubility. That's also valid. So it doesn't matter how you wrote it. I will try and be on the lookout that I don't accidentally mark you wrong if I grade quickly. So these questions were actually all the same. They were just on the quiz in a different order. I don't always do that. It really just depends on how much it's worth. On a test, I'm a lot more careful not to give the same question on both versions because cheating. All right, that's the whole thing, you guys. I'm going to index the video to make it easier for you to jump around from question to question. Please don't forget to be patient with yourself. Be patient with yourself. Please remember that I'm asking you to do much higher level work than you have done before. You've moved up to really hard classes in the high school. Give your brain time to grow into this, okay? So please, please, please don't give up. Don't quit. Just keep trying. Just keep approaching things. But do remember some really key things. Focus on your understanding. Focus on your application. And last but not really least, is do not forget that some things are going to be fluency tasks and you really need strategies for that. You have to use a fluency plan. You can't just look at things and expect them to go into your head. Okay. All right. I'll see you when we get back from the 3-day weekend. Bye.